Okay, good. So you're most welcome again. We are still proceeding with our series of revision chemistry, and this time around we are in for item 00, alright, 4, and this is strictly coming from section B part 1. Of course, it is in this part that now we look at the industrial process. Okay, in fact, in simple terms, how some substances are manufactured as per the areas of construct. Please, I advise you to go in the playlist, or at the end of this video I'll be putting for you a video and you see how item section B part 1, which contains item 3 and 4, is set and how it is marked. Alright, good. So with this we want to look at item 004, and simply here we're going to look at the manufacture of oxygen. And now specifically here we're going to look at the industrial manufacture of oxygen. It is a sensitive part, by the way. We all know that we have other methods of manufacturing oxygen, that is the laboratory way, but laboratory only provides little amount of oxygen. If you are dealing with something like a hospital where patients need much of the oxygen, then here we always opt for industrial preparation. And without wasting time, let's get there. Okay, so without wasting time, I think let's get started with the question. Okay, all right, good. So I have this question at hand. They're saying, get a laser pen. They're saying air is a mixture of different components. Please, topic air is in book 1. Topic air is in book 1. Okay, so air is a mixture of different components. It contains 21% oxygen. Due to a widespread of respiratory illness caused by COVID-19, there was an increased demand for oxygen by patients in hospitals. The government supply of oxygen is not enough and is planning to set up an oxygen production plant. Please, that plant means something like a factory. And since they're going to give it to patients, means that they need much of the oxygen in large quantities. Okay, so laboratory way cannot work, but industrial way can work. Okay, plant with minimal environmental impact. So as we are doing this, there should be no environmental impact. If it is there, then we must give a way forward on how we can mitigate it, or we can solve it. Okay, please, I said I'm going to be posting a video. At the end of this video, I'm going to post for you a video showing how we set item 3 and 4 and how it is marked as well. Please be there to watch it. It is going to pop up at the end of this video. Alright, good, let's proceed. However, the science club members in your school would like to know how the production process will be carried out. Of course, remember that produce oxygen. Okay, how the production process will be carried out. Task: as a chemistry learner, prepare a write-up you will use during the presentation. But remember, in our write-up, what are we going to dwell on here? Look, we're going to look at how oxygen can be produced. Okay, but how is it going to be produced? How can oxygen be produced in a plant? And the plant is more like a factory or an industry. That's the industrial preparation of oxygen. From what? From air. They've said air is a mixture of gases, and air contains 21% oxygen. So everything must start from air, but our aim is to get out the oxygen. Alright, anyway, that's where we're going to begin from. But again, as you're doing that, it must give us minimal environmental impact. Meaning, if there is any problem, like say for example pollution, you must as well give us in your write-up, tell us how can we solve that. Because in chemistry, we aim at providing solutions to problems, not necessarily bringing problems and we leave it them as that. Okay, so with that, I think here we're going to begin off with the description how oxygen can be manufactured on an industrial scale, that is in large quantities. Alright, good. So without wasting time, let's get there. Okay, good. Now I think we shall start with this. Let's start off with this. Please, I'm going to use pictorial first of all, such that we all understand what's going on here. Let's use pictorial and we explain one by one. Okay, if you're trying to use pictorial, Okay. Okay, so we are beginning with that. Now, since remember everything is starting from air generally has around 5 components. We have nitrogen, we have oxygen, we have argon, we have carbon dioxide, and we have water. In fact, argon is what we call rare gases. I think. But now remember, out of this, we only need what? Oxygen. So what do you think you're going to do? What do you think you're going to do? We only need oxygen. But the first thing to go with, the first thing we call off here is, the first thing we remove from here is this. I'll erase off this first of all. Okay, the first thing we shall erase off is this one here. We must remove carbon dioxide. Then, what do we use? What do we use to remove carbon dioxide? What do we use to remove carbon dioxide in simple terms? We use a reagent. In fact, to remove carbon dioxide, we simply use sodium hydroxide to remove carbon dioxide. Then to remove water, this water here we use what we call silica gel. We use what we call silica gel, or in simple terms, if not that, then we can opt for, instead of silica gel, or another word for it is silicon dioxide. Silicon dioxide. That's what we use. So in the first steps when you're describing, you must tell us how, what are the raw materials we're going to use here. We're going to use silicon dioxide and sodium hydroxide. Silica gel or silicon dioxide and sodium hydroxide, those are the raw materials. To do what? Sodium hydroxide to remove carbon dioxide and silica gel to remove water. Now I think that we don't have water, we don't have carbon dioxide. What's going to remain? Only 3 things, and we shall be seeing that. I think let's go and see that in the writing. Okay, I think with that, let's go and see how that can be put in writing. We're going to move in bits until we shall get there. Okay, let us see how this can be put into writing. We start with that first step. First of all, so we're saying that the process of production is carried out using air. The process of production is carried out using air, sodium hydroxide, and silica gel. In fact, the other steps we shall get them explained later, but of course you all know that the numbers, as far as item 3 and 4 is concerned, we base on, in fact, here we base on, first of all, we must know the raw material. Next, we must know the vessel. Next, we must know the physical process. Next, we must know the chemical process. Next, we must know conversion to the desired product. Next, we must now also know the coherence. Then next, we must know the CP, the complete process. All these must be fulfilled. Now we realize that here, okay, the process of production is carried out using air, sodium hydroxide, and silica gel. Now those are all raw materials. Okay, now you must know the vessel. Where do we put them? Like that. Now the first step you have explained that. Okay, now next, let's go there. Back to our pictorial stuff. Let's go back there. Okay, after getting there, I think let's move on. Okay, now next, after, remember, we have now removed our water and carbon dioxide. Now remaining with, okay, partly argon, oxygen, and what? Nitrogen. So we now bring that remaining part of air, and now we pass it, we filter it. Why do we filter it? To remove dust. We filter it to remove dust in simple terms. And realize that we have it here in steps. We have it here in steps. We have it here. So we have clarified on this that, okay, the atmospheric air is passed through air filters to remove dust, and now that is now a physical process to remove dust and smoke. Now to remove dust, that is now a physical process, PP, to remove dust and smoke particles. Okay, air is passed through concentrated sodium hydroxide solution to absorb or remove carbon dioxide, which is acidic. I've already clarified on that. Maybe let's give an equation how that carbon dioxide is called off using, okay, sodium hydroxide solution. Let's get there. I think we shall be getting the equation also soon or later. Let's get there. So that's our equation, and that gives us sodium carbonate and water finally. So realize that here we have sodium hydroxide plus carbon dioxide. It will absorb, therefore it will give us sodium carbonate and water. Now are you saying that this side oxygen is no more? Can you see that oxygen is no more? Oxygen is no more. Now this part here where we are mixing the sodium hydroxide and carbon dioxide is now our chemical process. This is now the PC, the chemical process, like that, a chemical, all right, process. The next, air is then passed through the silica gel or silicon dioxide to absorb water vapor. I would explain that. Okay, so carbon dioxide and water vapor are removed from the air before it is liquefied. Now in fact here, let's go and see the next steps using our pictures still. Okay, next, let's. Now the next process, when you're purifying, in fact, what you should know is that after removing water and carbon dioxide, we must, or in fact, you can even begin with removing the dust. Then after removing the dust, you come and remove water and carbon dioxide anyway. You can now do that. You can start with the filtration, then follow the easy, removing the water and carbon dioxide. We remove water using silica gel or silicon dioxide, and we remove carbon dioxide using sodium hydroxide solution. After that, after removing the dust, now remember we are now remaining with the okay, argon, oxygen, and nitrogen. Three things now. The two have gone. Now here, the next step, we must carry out two processes: liquefaction process and distillation, fractional distillation process. But remember, you are remaining with argon, oxygen, and nitrogen. Don't forget that. So the next step. Now, how is the liquefaction done? Liquefaction is simply done by cooling the air. How is the cooling the air done? Pressure is lowered. In fact, we must have high pressure. We must have high pressure there. We must have high pressure. Then we must compress. So as you're compressing in the liquefaction process, as you're compressing, you realize that here they will align themselves in this order. That after liquefaction, in fact, lowering pressure and lowering temperature, you also have to compress. Now when you compressing, like say for example, if you have a tin like this, then to compress means that if the air is in here, you come with something and you, maybe this one is a rod, then you compress and squeeze to make sure that you squeeze the air inside there. And when you're squeezing the air, you reduce on the area, and once you reduce on the area, the air will cool, hence forming a liquid. And that's what we call liquefaction. The word liquid means forming a liquid. Now with that, what must we know? Next, you realize that on this, now we are going by the color. You see that the red has negative 183 degrees. This one, argon, has negative 196 degrees, and the nitrogen has negative 196 degrees. Now, of these, which one has a low freezing point? This one is at a low temperature. This one is at low. Allow me use that. This one is at lower. In fact, let's clarify, do this first of all. All of this. Okay, in simple terms, you realize that this is for oxygen, this is for argon, this is for nitrogen. Now of these, which one has a low boiling point? This one has a low temperature. This one here is at high temperature. By the way, negative 183 degrees Celsius is bigger than negative 196 degrees. Please, in the negatives, the smaller the number, the bigger it is. So this negative 183 degrees is bigger than negative 196. So it means that this one here is at highest temperature, and this one is at lowest temperature. Now the next step, we are going to carry out fractional distillation. But remember, in the fractional distillation, the one with a low boiling point, the one at a low temperature boils off fast. So the one who boils off fast will be this one, followed by this, and the one who will escape last will be this. Okay, so that's what we're trying to mean here. And now let's go to the next step. Next step. Now in this step we must carry out what we call fractional distillation. In this step we must carry out what we call fractional distillation. We must carry out fractional distillation in simple terms. We'll clear this off. Okay. Now in the fractional distillation here, remember, I think let's just get everything here. Okay, great. Now remember, in fractional distillation, I'll explain this. In fractional distillation, please, what you must know is that now, since after cooling, liquefying the air, remember we're having 3 liquefied, and the nitrogen is here, argon is here, oxygen is here. Remember here, in liquefying, it means that in liquefying we were lowering the temperature, and as you're lowering the temperature at a certain level, you'll have your oxygen there. Then as you continue lowering at a certain level, you'll have your argon there. As you continue lowering the temperature, cooling the temperature, you'll have your nitrogen somewhere there. Now on the contrary, realize that as you are fractional distillating, in fractional distillation, the temperature now increases like that. The temperature now increases, and now the temperature is increasing. Who will come first? Nitrogen will escape first, followed by argon, and lastly oxygen. So you find that the nitrogen will go all away, and argon so shall remain with oxygen, which we need off in simple terms. So here, as they are heating at this level, this level, who will escape first? The one with the low temperature here will escape away from that area, followed by this one. Okay, I think allow me to erase off this. I will explain the other part. Okay, so this one here will be the first to escape. The one with the lowest temperature escapes first, like that, followed by this will escape from that area, and then lastly we shall remain with our oxygen there. Okay, in simple terms, that's what happens here, and you can really see that in the next step, nitrogen has gone away, followed by argon, and lastly we shall remain with our oxygen. And once this and this has gone away at their corresponding temperatures, -196 and -186, since they've gone away, we can now remain with our mighty oxygen. And then with that, we shall have, okay, manufactured oxygen on a large, right, scale. Let's go and see that in the written work. Okay, so you're still explaining here. I've explained everything almost. So realize that here, so air is then passed through the silica gel or silicon dioxide to absorb water vapor. I've explained that. Carbon dioxide and water vapor are removed from the air before it is liquefied. We must first remove before it is liquefied, because they can solidify and block the apparatus. Please realize that the carbon dioxide and water, now the water can become ice, and it may end up blocking the pipes. First of all, what you're meaning here is that these pipes here can be, once they block them, the ice may freeze. The ice may freeze, and it may end up, all right, blocking some of these pipes here. Blocking some of these pipes. That's why you first of all remove them in the very first, all right, place. Okay, let's get back to that. Okay, so okay, the air is now compressed at, now this is the compressing. Why are you compressing? Now we want to liquefy. Now we said you have to liquefy and also carry out fractional distillation. Compressed at 200 atmospheres. Now this is very high pressure, by the way, 200 atmospheres, and allowed to cool by making it escape into large space through a jet, like that. Now we have that in the picture somewhere here still. Just allow me to take you there. So here, like this. Okay, so as you are doing this, they will allow it to escape in a certain vessel. Like, say for example, here we have the oxygen, we have the nitrogen, we have the argon. So they can easily escape in these jets basing on their temperatures. But who will escape first? When they are cooling, oxygen first, followed by argon, followed by nitrogen. When they are fraction distillating, the opposite is true. Nitrogen first, followed by argon, and lastly is oxygen, which remains there, and is the one we are, all right, in need of. All right, good. So I think let's go ahead and conclude. So the air is now compressed at 200 atmospheres and allowed to cool by making it escape into a large space through the jet. Okay, good. Let's go and conclude. So now we're saying that The process of cooling is repeated several times to obtain the liquid air at about negative 200 degrees Celsius. So we repeat this cooling process such that we obtain the liquid air at negative 200 degrees Celsius. Alright, good. The liquid air is then fractionally distilled using a tower fractionating column. Now that is a vessel. Talked about that. Okay. Nitrogen boils off fast because it has a lower boiling point. I explained that. At negative 96 degrees, leaving behind oxygen with a higher boiling point. So here, the one with the low boiling point boils off fast. And I explained this statement here. I explained here like this and this. This one here is big. Meanwhile, this one here is what? Small. Take that into consideration. However much by the looks, you see that this one is bigger than this, but in real science, negative, this one is bigger than that. So this one has a low boiling point and it will escape fast. Escaping fast means boils off means that becoming a vapor. Okay, in simple terms. And that's how we can best describe. And of course, what is remaining behind? We are remaining behind with our oxygen, and then it can be taken up with into the hospitals and lives can be secured. That is now the industrial preparation of oxygen. But remember in the question they said there must not be environmental impacts. There must not be environmental impacts. Now let's see. Can there be problems? Can problems arise out of this process? Really? Let's go there and see. Okay, let's go there and see. Can there be problems? Okay, now say. Let's get it written here. So in a simple terms here, we are saying that the plant has social benefits. Now, I told you about this. We must now also give social benefits to the communities and the nation at large. By the way, this is true. The plant they put will not only bring problems, but also bring social benefits. Okay. And now you must talk about the uses of oxygen, the plant itself, then back to the uses of oxygen and nation at large. So, provides employment opportunities. Now, here, you must give us a benefit, explain it. Okay. So, provides employment opportunities. That is a benefit. Now, explain it. Hence, improve the income, thus, better standards of living. Alright, good. Okay. Development of infrastructure like roads, electricity lines, hospitals, schools, etc. But in the exams, you're not allowed to use etc. You can just say and so on. Please, in the exams, you're not allowed to use this. Okay. Improved road network, which will facilitate trade, hence improved income and better standards of living. This has been the point. Social benefit. This, in fact, you must give us a social benefit, give us an example, and also an explanation. Like, say, for example, social benefit, development of infrastructure. Example, roads. Explanation, improve the road network, which will facilitate trade, hence improve the income and better standards of living. Those are the social benefits. But don't you think there are some problems anyway? Let's look into this very fast. So here is that now it's saying the process of production of oxygen has the following side effects. Alright. Explosion of oxygen cylinder due to high pressure, which can cause other materials to catch fire, and this may result into damage of equipment and injury. Now this one is an accident. What if the cylinders burst? Don't you think people can die there due to high pressure? But again, in chemistry, we are not here to give you misery. We must as well give you a solution or way forward, how we can get this done, or how can we mitigate this, solve it. Okay, sir. This can be avoided by regular maintenance and monitoring of cylinders and keeping cylinders in cool areas. So that is a mitigation solution to the above problem. Let's move on. So finally, we shall say, now, don't you think this can bring about what we call air pollution? Yes, it can bring about what we call air pollution. Of course, just like any other factory, we expect what we call air pollution. Then, how can we remove it? Now we are in the side effects, or what you can call problems. Okay, air pollution by wastes. Air pollution by waste gases. Acidic gases can cause acidic rain. Yes. Now you have given the cause, the side effect, now an explanation, which leads to crumbling of buildings, lowering of soil pH, and corrosion of roofs of iron. By the way, okay, a crumbling Okay, in fact here, the acidic rain, I don't know if they've ever seen. Okay, but when you go in the areas of Tororo, where there is a factory of Tororo cement, the buildings nearby, when you look at the iron sheets, it's like they're even dark due to the fumes which come out of the factory. Not only that, but you realize that even the people around the Tororo cement industry, their teeth, when you look at their teeth, it is brown in color. That's an example of what we call pollution. But anyway, I can solve of that. This can be mitigated or avoided by fitting of catalyst converters in the exhaust pipes of machines to convert oxides of nitrogen into nitrogen and carbon dioxide, into nitrogen and carbon monoxide to carbon dioxide. Now, these catalyst converters, they can break down the nitrogen. They can break down the nitrogen, and they can also break down the carbon monoxide, which is a poisonous gas. By the way, this is one word. Carbon monoxide is a poisonous gas, but the catalytic converters can convert it into carbon dioxide, which is not that harmful to humans. And please, what you should know is that these catalyst converters are very expensive. That's why some of the factories tend to avoid them. Okay, much as is a mitigation here, but they're a bit expensive. So some factories just tend to avoid it, and they just decide to put the fumes directly into what? The atmosphere. Okay. Neutralize acidic gases before releasing wastes into the atmosphere. So this is another way to solve that. Now, the process of production is carried out using air. In fact, this has been a repetition. Here you can call of this. This has just been a repetition. This JoyoShare software, which we use in making this work, has, I think, when the network is not okay, you realize that it pops up some other work, but our whole stuff remains there. So here, as you're describing in your write-up, you must tell us how we can better get oxygen. Then, are there problems? How can we solve them? Are there benefits? Explain, and how. Explain, and also give an example. I think with that, let's see the way forward. Okay. All right, great. So both oxygen and nitrogen obtained contain negligible traces of noble gases. Okay, you realize that the other side we had argon and we didn't talk about it. So the oxygen may come along with some little argon in it. However, pure oxygen is now stored under pressure in oxygen steel cylinders. Yes, it is now stored for further use. Right. Very good. Now, and with that, we are going to finally end there. And of course, you realize that, please, we have the uses of oxygen here. We have the uses of oxygen as well. You all know them. But you are now ending here. Please, this item came from section B part 1, and the section B part 1, as far as chemistry paper is concerned, is where we have item 3 and item 4. Please, at the end of this video, I'm going to put for you how item 3 and 4 of chemistry is set, UNEB standards, and how it is marked. Please be there to watch it. It's going to pop up here in a few seconds. All right, it's right there.